In high-level system design, let's start with something simple. Let's say we have servers which are emitting these metrics, or rather we are collecting these metrics like CPU, RAM, disk utilization. So let's say collector service, and we are storing this information in some relational database. As always, we are not making any choice in high level system design. It could be simple Postgres or MySQL database. So these metrics are being emitted and this service is saving into this database, and the dashboard would be able to query these database for loading the metrics in the graph. So we will have the dashboard, which is a UI that can query this database. So if you see here, how does this servers emitting these metrics and how does this service can capture these metrics so that it can save into the database. From here, we can start thinking about the push or pull mechanism. Either these servers can push these events to this service via some API, or these service can periodically call these servers to get these events. So I can give an example of Prometheus. If this is a Prometheus service which expects these servers, or in other cases services, exposes an endpoint slash health, so that this Prometheus can periodically call that endpoint to fetch the health of these services. So this is a pull mechanism which Prometheus follows. In case of AWS CloudWatch, which exposes an endpoint to the clients, so client can push health events to the Amazon CloudWatch. So this is a push mechanism. So from here we can start something, build our own system and explain the trade-off between push versus pull mechanism with pros and cons. However, as such, either of these works until we are good with these concepts and examples. In the case of servers, how does this push or pull mechanism would work? For that reason, we would need to have some kind of a services running in these servers which can either push or pull these events to our collector service. So let's say we have a service called agent which is running in these servers in the background all the time, which should help us to either push or pull these events to our collector service. So these agents are having a control over these servers. So these events can get these metrics like the CPU, RAM or disk utilizations on these servers and can periodically call this collector service API to push this information, and this service will save this information to the database. From the dashboard, we can query based on these metrics and load the graphs in our dashboard in a representational format to know the performance or state of any specific servers or the collections of servers or the collection of metrics based on the date and time range. We also need the alerting feature, which is another core functionality of the system. So from the functional requirement, collecting the data, storing the information dashboard, creating the alerts and rules. So let's touch upon that as well. We need the alerting system, which could be a cron job to start with. Let's say this is a cron job which is periodically querying these database, and whenever it encountered that any specific server is down or threshold is being reached for the RAM or CPU utilization, it can call the notification service here to send the SMS, email, or call, which we would not get into detail, but let me point it out here. We can create the alerts into the system, and based on these alert, this cron job would run. So we need the alert service as well to create the alert and the alert database that we get into detail when we go into deep dive. But as of now, if you would see that the basic end-to-end functionalities is working fine, uh, right from right from capturing the events on these servers based on from these agents, storing this information in the database, loading into the dashboard, and triggering the alerts based on the events. But this is not a scalable system, though it satisfied all the core functionalities and we are able to explain the end-to-end flow. So let's get into the deep dive. Let me copy the basic flow diagram for the deep dive. In the deep dive, start thinking about the bottleneck in the system for making it scalable. So if we have hundreds and thousands of these servers, let me create some to understand the problem statement here. So we have these servers continuously sending the events. So it could be millions per second event sending to this single service, so that would be overloaded and would not be able to capture a single server of instance would not be able to capture all this information. These hundreds and thousands servers continuously sending these metrics to the single instance of this service, so it would not be able to handle the load. So now we have identified we would need to increase the load on these servers. Even if we scale these services to multiple instances, there is another issue what we see. Currently, we are following the synchronous communication that is not scalable for these kinds of write heavy system. So we need some kind of asynchronous, or rather decoupling these services and database to handle such a write heavy load and scale individually and independently. So let's introduce a message broker in between. It could be managed service from the cloud, and like SNS, SQS from AWS. Also a popular message broker which works based on the topic and queue, Kafka. Let me create some space here. So we need multiple instances of these services as well. And if we need a multiple instances of this service, we would need to have some kind of a load balancer. So let's introduce the load balancer here as well. These servers are sending these requests to this load balancer, and this load balancer would be sending the request to these instances, to these multiple instances of the service. These services is just publishing the message to the Kafka topic. Here we need the load balancer. Now you can see why I have not used the API gateway here, why I have used the load balancer. And that's the differences. That's the difference between load balancer and API gateway. So this is not a public facing servers. Probably this is wrapped under a virtual network here. So because this is a on premises infrastructure, we do not need uh, authorizations for these events or write heavy events. We don't, and we will also handle the rate limiting or aggregation from the customizations of these services. So we do not need the features of the API gateway, and we wanted to balance the load between these multiple services. That's why we are using a load balancer. Let me remove this back. Now we are able to write these metrics from all these services, and we decoupled using the Kafka. And Kafka now has all these metrics. We can scale the Kafka depending upon the load. We can partition the Kafka based on the matrix name, or based on the machines, or based on the host. Next is to consume these messages and save in the storage. For that, let's introduce the consumer for these Kafka messages and store in the database. And for sure, we don't need this relational DB because this is not tuned for write heavy. Also, this is not good for querying the large range. For that, we would need, so let's delete this and this, move this dashboard to the bottom right now. This service, this would be the consumer. This consumers would be the cluster group of cluster Kafka consumers, which is nothing but set of services consuming this Kafka messages and storing into a database. This database we need to talk about. This database should support the range query. So this is a database, and if we wanted to this database to support the range query, so let's include the query service. This query service can make the range query like for a specific machine from so and so date and time. This database should be highly optimized to serve the large range queries that can be populated into this dashboard. So we can propose something like this should support the large range queries. So we can have a online analytics processing database, which is OLAP. Another is the OLTP, which is optimized for transaction. This database is optimized for the range queries. The examples are Snowflake database. We can propose the Snowflake database for this OLAP operations. These consumers are saving these messages to this OLAP database.